Let's say we have a set of ingredients and we want to use AI in order to generate some recipes based on those ingredients. In this video, we're going to use Langchain and Streamlit to build an application that lets us interact with the OpenAI APIs and fetch these recipes based on some input from the user. And we're going to use Langchain to chain up different operations in this video, and this allows us to create more advanced use cases around LLMs in a nice Pythonic manner. Now, Langchain is a framework for developing applications that are powered by language models. So let's dive in now, and we're going to look at the Langchain documentation. If we click on the Quick Start guide here, we are taken to this quick start, which I'll link in the description of this video. And you can see here we can use the pip install Langchain command in order to install Langchain into our environment. So we're going to go to VS Code, and I have a very simple setup here. We have a .env file with an OpenAPI key, and if you're following along with this video, create this .env file and put your OpenAI key as the value for this. And then we have also a main.py file, and here we're using the python.env library and calling this load.env function. That's going to load the values from the .env file into the environment, and then you can load up your API key using the os.environ dictionary. So at this stage of the app, on line 7, we have an API key that is going to allow us to interact with the OpenAI API. Now I've opened a terminal in VS Code, and we're going to copy the pip install Langchain command. That's going to install this into the environment. Once that's installed, at the top of this file, I'm going to import from Langchain's LLMs module the OpenAI object, and that's going to allow us to interact with OpenAI's API in order to send requests and send prompts to the ChatGPT model and then get back responses. So below our API key, let's instantiate an OpenAI object and store that in a variable called LLM. I'm going to pass the key here with the OpenAPI key keyword argument, and we'll set that equal to the key that we're getting from the os.environ dictionary. And let's also set another value, and that's the temperature. I'm going to set that equal to 0.9. Now, if you're wondering what the temperature value is, if we go to the OpenAI documentation here, you can see this section for temperature. This defaults to 1, and it can take values between 0 and 2. And higher values such as 0.8 will make the output more random, and lower values like 0.2 will make it more focused and deterministic. So the higher the value, the more varied and random that output may be for your particular queries to the language model. Now, if we go back to Langchain's documentation, because we're using OpenAI, we also need to make sure we are pip installing this library into the environment. And this is the library that's actually going to allow us to interact under the hood with the OpenAI API. And we're going to use that via Langchain, but we do require the underlying library. So once that's installed, we have access to this LLM object here. And this is an instance of the OpenAI object. Now, the LLM object is a callable. We can actually call that and send a prompt, which is then going to generate a request to the API. So what I'm going to do is create a variable here called 𝗖𝗵𝗽𝗀, and I'm going to call this LLM model with a string prompt. And the prompt I'm going to pass in here is write a 𝗖𝗵𝗽𝗀 about the Python programming language. And what we can do is we can print the response, the 𝗖𝗵𝗽𝗀 that's coming back from the API here. So if we now run this program with python main.py, hopefully we are going to see a 𝗖𝗵𝗽𝗀 coming back from OpenAI, and that's a response from the language model based on a prompt that we provide. And you can see the 𝗖𝗵𝗽𝗀 below. Python is my friend, elegant and powerful code makes development fun. Very true. So we have a 𝗖𝗵𝗽𝗀, but let's move on to something a bit more useful now. What we're going to do is build a Streamlit application that lets the user enter details, and these details are going to be used as part of the request to OpenAI, and we're going to use Langchain to manage all of these interactions. So we have a large language model here. We've seen how we can send a basic prompt, but what we're actually going to do now is create something called a prompt template. And a prompt template refers to a reproducible way to generate a prompt. This consists of a text string or a template that can take in a set of parameters and then generate a prompt based on filling in those parameters into the template. This is kind of like Jinja 2 or the Django templating language, where you can provide dynamic values or user produced values into the context of a larger template. So let's go back to VS Code, and at the top of the file I'm going to bring in a new import. From the Langchain.prompts module, we're importing the prompt template object. And what we're going to do just below here is I'm going to remove the 𝗖𝗵𝗽𝗀, and what we're going to do is create a variable here called PromptTemplate, so prompt_template, and we're going to instantiate that prompt template that we have imported from Langchain. And we want the user to enter a set of ingredients. So I'm going to create a template here. This is a keyword argument we're passing to the prompt template, and the template that we're going to use is this one here. Give me an example of a meal that could be made from the following ingredients. And then you can see this here, this is passing in a value, an input variable of ingredients, and this is going to be provided by the user. So ingredients here is called an input variable. We need to tell the prompt template about all of our input variables here. So that takes another keyword argument called input variables, and we can pass as many as we want into the template. In our case, we only have one, and it's called ingredients. So this is a reproducible prompt template. We can pass ingredients such as rice or tomatoes in here, and it's going to generate a different string based on what is input. And we can use this to control what kind of prompts are being sent to OpenAI by generating a template and taking user input and then passing that into the template. Now let's see quickly how we can actually render or generate a template here. If we go down below this, we can use the PromptTemplate.format function, and we can then pass any input variables into the prompt template. And what we want to pass in is the ingredients that we want to use to actually generate a recipe from those ingredients. So the ingredients I'm going to pass in here are rice, peppers, tomatoes, and lentils. And let's store that in a variable called template, and then we can actually print that template out to see what that looks like. So if we rerun python main.py just below here, you can see the output here. Give me an example of a meal that could be made with the following ingredients, and it has filled in that placeholder or that input variable with what we have passed in here in the format method. So what we want to do now is do something similar with Streamlit and actually let the user select these lists of ingredients and then pass them in based on that user input. So what I'm going to do is remove this template code here. We'll keep the prompt template and the LLM object, and now we can start writing some Streamlit code. So I'm going to give this a title of meal planner, and we can do that with the streamlit.title function. And at the top of this file we have imported Streamlit as st. What we need to do now is get the user prompt, so we can set a variable called user prompt, and we're going to set that equal to a Streamlit text input, and we can give that input a label, and our label in this case is going to be enter a comma separated list of ingredients. Now once the user's entered the ingredients, let's create a button that's going to allow them to send that to our application. So let's create a button here with the text of generate, and if that button is clicked, the if statement here is going to evaluate to true, and we also want to chain an and on that and make sure that the user has entered a prompt. Now at this point what we're going to do is generate some output here by calling the LLM object that we instantiated above, and that's the OpenAI object on line 11 here. What we need to do is pass in our prompt template to the LLM object, and again we're going to call in this case the .format function and set the list of ingredients equal to what the user has entered in the user prompt on line 19. So that's going to then call the OpenAI language model, and the response is going to be stored in a variable called output, and we can just use the streamlit.write function to write that output onto our page. Once we've done that, we can clear the terminal, and I'm going to use the streamlit run command, and we're going to run the main.py file, and that's going to generate a Streamlit application on the browser. And this is the application here. It's called Meal Planner. That's the title we gave it. And below that we have the Streamlit text input, and we can enter our ingredients here. So for example, rice, peppers, and lentils. Let's enter that and generate a meal from that input. And you're getting this response here of a particular meal that you could make with those ingredients. And that's the goal of our application: take a list of ingredients and generate a meal from those. But what we can do is actually make this process a little bit easier using LLMChain objects from Langchain. And the documentation says that using an LLM in isolation might be fine for some applications, but more complex use cases, they involve chaining together LLMs. And that chaining can occur either with other LLMs or with other experts or external services. So chains allow us to combine multiple components together to form a single coherent application. And we're going to start by using the LLMChain object from Langchain. So we're going to import that from langchain.chains. Let's import the LLMChain object. And what we can do below is, when we have our LLM object, our OpenAI object, and also the prompt template, what we can do underneath that is create an LLMChain. So we're going to call this meal chain. And we're going to set that equal to an LLMChain where we can pass some keyword arguments into that object. First of all, of course, we want to pass the language model itself, so we'll pass that in, and we're also going to pass the prompt template in, and that's done using a keyword argument of prompt. So we'll set that equal to the prompt template, and I'm also going to set verbose equals true here. Now once we have the meal chain, we're going to use that down here after we click the button. So instead of using the LLM directly, I'm going to remove this line of code, and that'll also remove the PromptTemplate.format method. We're no longer going to need that, and instead we're going to use our new meal chain object, and we're going to call the .run method on that. And because we've passed the prompt template into the LLMChain object above, when we call .run on this object, all we need to do is pass in the ingredients. We don't need to reference the prompt template, so let's pass in the user prompt as the ingredients. Now we can test if this still works, but before we do, you might have noticed that when we actually send the request to OpenAI, there is a bit of latency before the response is received. So what I'm going to do is create a Streamlit spinner object here, and we can do that with this context manager with streamlit.spinner, and we can give it a bit of text as well. And we'll give it the text of generating, and then we can tab over the 2 lines of code just below that. If we go back to our application, let's now enter some ingredients here, and we can generate the response from the API. And again, in the background, this is using the OpenAI language models, and it's generating a recipe in this case based on the input that we've provided here, and also based on the prompt template that we've given to the LLMChain object, as you can see now in the code just up here. And now we have a meal coming back, and that's printed onto the page. So let's just reiterate what's going on here. We create a language model on line 12, and we're using OpenAI, although there are other options available in Langchain. And one of the benefits of Langchain is that it gives you a unified interface to different language models, no matter whether you're using OpenAI or perhaps Hugging Face or other language models. Once we've created the language model, we then generate a prompt template, and this is done by providing a template to that object which contains the text or the prompt that we want to send to the language model. And we can fill that in with some dynamic parameters such as this here, where we can pass a dynamic set of ingredients to the template, and that's then going to be filled in, and this is called an input variable that you can pass to the prompt template. And finally, we are creating an LLMChain object that combines both the language model and the prompt template into this object that we can then call the .run method and provide to that run method any input variables required in that template. Now what happens if we want to use this output that we're getting back here, and we want to provide that as input to another second step in this process? For this we can use something called sequential chains. And sequential chains are particularly useful when you want to take the output from one call and use it as the input to another call. And that's exactly what we're going to do. We're going to take the output from our first call, which is the meal, and we're going to rewrite that output in a different tone or style of voice. And let's imagine that we're going to rewrite the meal plan in the voice of a New York mafia gangster. So what I'm going to do above here, just next to our prompt template for the meal, I'm going to create a second template here, and that's called gangster template. And let me move this to a new line. So the template here says, rewrite the meals given below in the style of a New York mafia gangster. And again, we have this input variable of meals, which allows us to pass a value into the prompt template. And these meals are going to be coming from our initial query to the OpenAI model, which is then going to return that response with the meal we're going to then pass into this template. So this is our template. What we now need to do is actually create a prompt template object here. So I'm going to call this gangster template prompt, and we can set that equal to a prompt template where we pass in the template equal to this gangster template that we just created above, and we also pass in the input variables for that template. In our case, that's going to be the meals. So we're taking this string template above and we're passing it into the prompt template, and we're providing the input variable of meals. So we can now use this gangster template prompt, and we can actually generate another LLMChain where we pass the above prompt in as the prompt keyword argument. So let's go below the meal chain, and we're going to create another chain here called gangster chain that is equal to an LLMChain object. And again, we're passing in the large language model to this chain, and we're also going to pass in a prompt equal to the gangster template prompt. And we can also pass verbose equals true again, and that's going to print out some output to the terminal while this is in operation. So what we have here are two LLMChain objects. Firstly, the meal chain, which gets the meal, and secondly, a gangster chain, which we want to use to rewrite that meal that we're getting back in the style of voice of a New York gangster. What we now need to do is connect the two chains up into a sequential chain. And the sequential chain does exactly as you would imagine. It takes a sequence of these chains and it runs them sequentially, one after the other, and then generates output at each turn and passes that output into the next stage, the next chain. Now if we go to the top of this file, we have imported from the Langchain.chains module the LLMChain. We're also going to import the SimpleSequentialChain object. And if we go down here below to this gangster chain, just below that we're going to create an overall chain that we're going to use to connect them together. And we can instantiate the SimpleSequentialChain here, and to that we can pass a list of chains. And the two chains that we're going to use are the meal chain and also the gangster chain as well. We can then use this overall chain that combines the two LLMChain objects above. We can use that here to generate our output. So let's replace that with overall chain.run. And we can pass the user prompt in here, and we don't actually need the keyword argument of ingredients now when we're using the sequential chain. We can just pass in the prompt for the first chain. And if we go back to our application and we paste in some ingredients, when we generate the meal plan, we're hopefully going to see the output coming back, this time in the style of a New York mafia gangster. Now while that's generating, if we go to the terminal, you can see that we're getting back the messages here. For example, this one saying that the chain has been finished. And we see this because of the 𝗰𝗵𝗽𝗀𝗲 keyword argument that we're providing to each of the chains. Now if we go back to our Streamlit application, you can see the final output here, and this has been written in the style of a gangster from New York. And that starts with the line, "This here's one mean meal, boss." Now my very Scottish accent does not properly do a line like this justice, but what hopefully does make sense is the fact that we are creating two chains here, a meal chain that gets back meals from the OpenAI based on a prompt, and then it takes the output from the OpenAI language model and it passes it as input into the next chain in this sequential chain, which is the gangster chain. And that is another LLMChain object that has its own prompt template. And when we call run, it's going to then send the request to OpenAI with the new template for the second chain here. And the output we get back is the gangster version of the meal plan, which you can see on the Streamlit application here. So that's a simple use case of using a simple sequential chain from Langchain in order to connect up two or more chains into some coherent structure that you can then use and reproduce in your applications, and users can then interact with those chains in a way that they don't need to know the underlying prompts, they don't need to know how it interacts with OpenAI, they just provide input and the prompts take care of formatting that, and Langchain will take care of sending the requests to OpenAI and chaining the responses together. Now one thing you might have noticed is that when we're writing the output to the page, the only output we're getting back is the gangster version of the meal. We're not getting the original meal before it was changed to that gangster version. Now if we go to the SequentialChain documentation, we can actually change this up a little bit, but in order to do so we need to change from the simple sequential chain to this object here, which is the sequential chain. And as it says, not all sequential chains are going to be as simple as passing a single string in as an argument and then getting a single string as an output for all of the steps of the chain. Now in our case, we might be also interested in the output from the meal chain, which is just the meal in normal English text, as well as getting this gangster version of it. And if we're interested in getting the intermediate outputs, we can pass a keyword argument called output key here, and we can give the output from this process a name here. In our case, we'll call it meals. And we can copy that keyword argument down to the gangster chain as well, and we'll call this output gangster meals. Once we've added these output keys to the chains, what we need to do is change what we're calling here. Instead of simple sequential chain, we're going to call another object here called SequentialChain. And that gives us more customization over this process. So if we go to the top, we can remove this import and replace it with SequentialChain. And again, that's coming from the Langchain.chains module. So now we're using SequentialChain. What we're going to do is we're going to pass some other keyword arguments here. And I've reformatted this so that each keyword argument is on its own line. So we're passing in the chains. But now because we have these keys, we also need to pass in input variables and output variables. So the input variables to the first step in the process is just going to be the ingredients that we pass to the prompt for the meal. And the output variables are going to refer to the named variables that we have added here, the named keys that we've given to each chain. So it's going to be the meals for the first chain in the process, and for the second chain that was called gangster meals. And what this means is that when we get the output, there's going to be two parts to that output. The first one is going to be called meals, coming from the initial chain in the process, and the second from the last chain, the gangster chain. And again, we can set 𝗰𝗵𝗽𝗀 in the sequential chain here. And the final thing we need to do is we need to change how we're calling this sequential chain. It's called overall chain. Beforehand, we're using the run method. But in order to call a sequential chain object, what we're going to do is go back to the documentation. And let's have a look at how this is called. You can see down below here, what we're doing is we're actually instantiating the object and we're passing a dictionary of key value pairs representing the input variables. So let's copy that into our own structure here. So we're going to remove the call to .run, and what we're going to do is we're going to pass in the input variable ingredients and set that equal to the user prompt. Now the output that we're getting back from the sequential chain is going to consist of two parts, and that's because we now have two output variables here. So let's go down and we're going to create a structure around that. I'm going to remove the call to streamlit.write, and what I'm going to do is create a two column system. So we're going to create two variables here called column1 and column2, and then we're going to call the streamlit.columns function, and we pass in the number of columns that we need here, and that's 2 columns. And on the left hand column, we want to write the original meal that's coming back from the first chain in this process. And then on the right hand column, we want to write the gangster version of the meal. So in column 1, what we're going to do is call the .write function. And what we want to write here is the output, but we want to get the meals output variable from that output. If we scroll up here, you can see the meals is one of the output variables that we're getting, and that refers to this first LLM chain where we have an output key of meals. So we're getting that out of the sequential chain, and we can do that using this syntax here. So we're taking the output and we're accessing a key called meals here, and I'm going to copy that down below, and we're going to reference the gangster meals as the second output, and we're going to write that to column 2. If we now go back to our page here and we paste in some ingredients and then we click the generate button, hopefully we're now going to see 2 columns in the output here, where the left hand side contains a meal and the right hand side contains the gangster version of that meal. And we can see the output below, and this has given us actually more detailed instructions than before. We have proper instructions on the left which contain all of the ingredients and then a list of instructions. And then on the right hand side we have a very different version of that recipe, and you can see the gangster version of this is replacing words such as the with the word da. And it's quite fun actually to read through these examples and see what kind of output is generated. And while this might not have many real world use cases unless you're planning to write a cookbook in the style of a gangster, the process of using Langchain to do this, using these objects such as the LLMChain and the prompt templates, and then combining them together with chains such as the sequential chain, it allows you to build complex pipelines and workflows using language models, and it allows you to provide applications that can take basic information from users and format it in a way to get an optimal response from a language model. And we can change these templates in any way we want. So for example, if we go up to the prompt template here, rather than saying give me an example of a meal, let's change that to 3 meals that could be made with those ingredients, and then we can get more ideas from the prompt, more ideas from the responses, and then more text in the style of that New York gangster. So let's go back to the page and we're going to paste in that same list of ingredients, and hopefully this time we're going to get 3 meals back from the language model, and we're going to see them displayed on the page using Streamlit. And that's exactly what we've got here. We've got the meals on the left hand side, and each meal has its gangster version on the right. And if you want to extend this even further, what we could do is go back here, and this gangster template, we could make this general. We could give the user the option to enter a particular style rather than just hard coding the New York Mafia gangster. Rather than hard coding that, we could allow users to say write this in a particular style, and hopefully the model will do that. So let's summarize what we're doing in this video and how we're using Langchain. Langchain contains an LLMs module for language models, and that provides a general interface into different types of language model, for example OpenAI and Hugging Face. We then instantiate the OpenAI object and create a language model, and then we also create a prompt template that we can use, and that prompt template is how we can control which kind of prompts we are sending to OpenAI when a user, for example, enters some data. In this example, we're getting some ingredients from a user based on a Streamlit text input field. And what we're doing, if we scroll down here, is we define an LLM chain called 𝗰𝗽𝗽𝗀𝗻, which takes our language model and that prompt template. And we also define a second chain called 𝗖𝗵𝗽𝗽𝗀𝗲, which takes the output from the first chain as input and then generates a second output. And that chain has its own prompt template as well, and we can create as many of these as we want and hook them up using these sequential chain objects that we've imported. And the sequential chain takes a chains argument, which is a list in Python, and you can pass as many chains as you want to the sequential chain, and as the name implies, it's sequential. So it's going to run the first chain, which is 𝗰𝗽𝗽𝗀𝗻, and it's going to take the output from that and pass it as input to the next chain in the workflow. And we've created a small Streamlit application around these Langchain objects. We have the user prompt where the user can type text in, and then we're passing that text to our sequential chain in Langchain. And when we call this sequential chain object on line 59, what's going to happen in the background is that Langchain is going to kick off the calls to the OpenAI API, and it's going to send the initial chain, the initial prompt to that, and it's then going to coordinate the inputs and outputs for each chain in this list of chains that we're passing in. And we can specify the output variables that we're interested in along the way, and finally we can write the data that we're getting back to the Streamlit page And that's exactly what we see here on this meal planner application. So thank you for watching this video. If you've enjoyed this video, please like and subscribe. If you're interested in more in-depth content on Langchain, please let me know. This is a new Python library that is very popular at the moment, and it's riding on the popularity of these language models. So thanks again for watching. Please like the video if you've enjoyed it and subscribe to the channel, and we'll see you in the next video.